the curve with equation y is equal to 2 plus k sine x passes through the point with coordinates pi over 2, comma negative 2. So what should we do? Find the value of k and the greatest value of y. So our task is to find k, and also we should find the greatest value of y. So let's find k. Whenever you are given a point, this is x, comma y. What does it mean? It means that when you take the value of x, you must get y. So in the equation, you take x, you have y. Meaning in our equation, we have y as negative 2 if we take the value of x to be pi over 2, like that. But what is sine pi over 2? Pi over 2 is 90, remember? Sine 90 is 1. So what we have is negative 2 is equal to 2 plus k multiplied by 1. If we take this to the other side, we'll have negative 4 is equal to k. So the value of k has been found. So easy. Now that we have the value of k, what do we do next? We find the greatest value of y. Now sine function, the function of sine, if you can remember very well, when you are doing the sketches in class, you observe that it went as far as 1, got back to negative 1, and went back to 0. So the greatest value of sine is 1. The lowest value is negative 1. This is how far sine and cosine can go. Even cosine is the same. I mean cos. It also goes as far as negative 1 and 1 only. If you find anything up here and sine reaches there, it means that there was some shift done. There was some stretching, which we call the amplitude. Without the amplitude, sine can never get there. This means that for us to look for the greatest value of y, it will happen at negative 1 or at positive 1, depending on our function. So we'll have y is equal to 2 plus k has been found to be negative 4 multiplied by sine. Now let's see. If we do 1 here, we'll get 2. I mean, if we do sine 1, not necessarily sine 1, if we get a value of x, that gives us sine to be 1, which is 90, we'll get 2 minus 4, which is negative 2. Let's also see what happens at negative 1. So we'll have 2 plus negative 4. When sine gives us negative 1, what will happen is that we'll have 2 plus 4, which is equal to 6. This means that sine, that y, will have its greatest value as 6. So if we were forced to sketch this function, we would have sketched it and it would have been going up. I mean, it would have been going down instead of going up. Because the whole function now could be written as y is equal to 2 minus 4 sine x. So that would have been the story.
Sir.
Hello.
So why did you choose to use for the amplitude 1? So can you choose any number like for the amplitude? Maybe you, like for example, you gave an example of 2. If the graph stretches by 2, which is the amplitude, you can use 2 to try to find out the maximum y value.
No.
Okay, maybe you can try to shed more light on
so
that.
we have suspended the amplitude. We left it alone there because in this case, since our function can be written in this form here, what is the amplitude? Okay. Amplitude is what? The modulus of -4, which is 4, is it?
Yes, yes.
Now we avoided the concept of that amplitude. We just left it there and went to the actual sign and assumed that the amplitude is not affecting anything and do the question as though we had no impact from the amplitude, but just looking at what the original sign gives us. So the original sign x away from the k goes as far as 1 and -1. So we check what happens at its least at -1 and also at its greatest at 1 and take it back in the equation of y and see which number will be bigger than the other, and the biggest number becomes the greatest value. So that you guys, as you practice, you can sketch this function and see if you understand what it means to sketch sine.
Sir.
Hello.
Yes, sir. So what if we took, let's say, the amplitude into consideration?
Okay, let's sketch the function.
Yes.
Let's sketch it and see what we'll get. So in sketching the function, so I'm now also answering question 8 because we're introducing the sketches now. So in sketching the function, you need the amplitude. Remember, your function must look like this: a sine bx plus c plus d, and call the period 2 pi over b. The amplitude, the modulus of a, the horizontal shift, bx plus c equated to 0, and then solve for x, which is -c over b, and then d is called the vertical shift. So if you go back to our equation, y is equal to 2 minus 4 sine x, we can say that the amplitude is the modulus of -4, which is 4, that the period is 2 pi over 1, which is 2 pi, horizontal shift is 0, and the vertical shift is 2. So you can sketch our function. So we'll talk more about the sketches. We are just doing this to find a way of explaining how the greatest value is going to be 6 and the least unknown. So to sketch this function, you get what we call the scale, where you divide the period by 4 because you have 4 critical points in the period of the whole graph of sine. There's a question from Doris. Doris, you can ask the question. Okay, I'll pause when she starts talking. So the period is 2 pi. So we divide 2 pi by 4, giving us pi over 2. So that from 0, you go to pi over 2, which is our scale, and add pi over 2, you get pi. Another pi over 2, you get 3 pi over 2. Another pi over 2, you get 2 pi. You don't go beyond 2 pi because that's your period. And the amplitude is 4. So we have 4. We also have -4. In fact, the method I want to use to sketch this thing does not require us to put the amplitude on the graph. Then now you get the critical number that we have here: 0, 90, 180, 270, and 360. So you say, what is y when x is 0? You know that sine 0 is 0, so we get 4 by 0 here, which is just 2. So we'll have a point at 2. So that is 2, 0, 2 there. Then you go to 90, get y is equal to 2 minus 4 sine 90. We also know that sine 90 is 1. So we get 2 minus 4, which is -2. So we go to -2 at this point and have a sketch. So we put a point there. Then we proceed to pi. Y is equal to 2 minus 4 sine pi. Now what is sine pi? Sine pi is -1 minus 1, giving us 2. No, sine pi is 0. Sine pi is 0. So we get 2 minus 0, which is 2. So we'll go back to pi, 2. And then go to 3 pi over 2. That is 270. 2 minus 4 sine 270, which is 3 pi over 2. Sine 270 is -1. So we get 2 plus 4, which is 6. So we'll have a point at that guy, 6. So we put 6 somewhere here. So this is our 6. And then you go to 2 pi. So 2 pi, what is sine 2 minus 4 sine 2 pi? Sine 2 pi is 0, so we'll get 2 minus 4, 0, which is 2. So you substituted 2, so we get the point 2 again. Then we can draw the graph now. It's coming down like that, going up there, and then come down there. What is the greatest value of y? For sure, it is 6.
Yeah.
Which is what we found here, is it?
Yes, sir.
So it has been explained in another version.
Yes, sir. This is powerful.
Okay, let's go to the next question. Question 6. Question 6, given that 0 is less or equal to x, which is less or equal to pi. Now remember, pi is 180. That's how you convert from radians to degrees. You use pi is equal to 180. Find the values of x for which. So find the values of x for which 1 sine 3x sine 3x is equal to It's not labeled. We only have one function here. This is y is equal to 2 minus 4 sine x. So sine 3x is equal to 0.5. 0.5 is the same as half. So I write it in the fraction form. To avoid issues when solving such questions, if what you are seeing here as an angle is not directly x, it is being multiplied or added to some things, you let theta take that position so that you deal with sine theta is equal to half. When you have sine theta is equal to half, you know all you are looking for is an angle that gives you half there. And that angle is 30 for sine. That is the first angle in the first quadrant, where it's in what do you mean by time up? You guys have class at 11?
No, sir, let's keep learning.
Yeah, I was told that your class is at, is it 12?
It's 12 hours, sir.
Yeah, so
Yes, it's 12.
So I'm given 10 to 12. No one should run away. Okay, so sine theta is equal to half means that theta is equal to 30. But because we are dealing with 0 to pi, meaning that our answers must be in radians, so that will be pi over 6. But sine is also positive in the second quadrant. So what we do is we are calling this theta a theta here as a reference angle. So we can also go in the second quadrant and get the reference angle using that 30 now. Okay, so here it will be 180 minus the 30 we found in the first quadrant, so that we get 150. But we must convert 150 to radians. So what we do is we'll say theta is also pi minus pi over 6. The same as 180 minus 30. So we'll get 5 pi over 6, like that. That's the thing. So far what we have is that 3x. So far what we have is that 3x. Remember, theta is 3x. So once you find theta, you go back to 3x and say 3x is equal to pi over 6, implying that if you divide by 3, you divide by 3, x is pi over 18. That's the first value of x. We also have another one, 3x, meaning theta is equal to 5 pi over 6, so that we get x. When you divide by 3, you get 5 pi over 18. So we have two values of x. Okay, so we have 5 pi over 18. Then from there, because the x that we have there is being multiplied by 3, it's possible that you can go outside 360 using theta, and then so that when you divide by 3, you still come back to the given range 0 to pi. Now let's try and see if it's possible to get such a thing. So using 30, we can go around 360 and add 30. I've looked for an angle which is coterminal to 30 and see this is 360 now plus 30, which is 390. Now let's see if when we divide 390 by 3, we can still come back to between 0 and 180. So there we'll get 1 3, 0. 130 is less than 180. So that is also a required angle. Okay, so we have 3x is equal to 390 divide by 3 and get the value of x to be 130 multiplied by pi over 180 so that we can change it to degrees. So we have 13 pi over 18. That is also the value of x. Next, we go to the other one, this 150. So go around again and see if what we get when divided by 3 will still land us between 0 and 180. So what we have there is 360 plus 150. That is 0, 1, carry 1, and then 4, 5, 5, 10. Let's see if we divide by 3 here, what we'll get. We'll get 1. We'll get 170. So 170 is less than 180. So this means that we can also bring it here. Say 3x is equal to 170. Divide by 3, divide by 3. So we get x is equal to 170 over 3. Can this be simplified? Let's see. In 15 that it can't. So we just change it in this form. We'll change it to degrees. At least the 0 can go. So we have 17 pi over 3 by 18. Let's see. There we get 4 and then 5. 17 pi over 54. Okay. So that is what we have also here. This should be 170 for sure. Is it? It looks like. Okay. So do we have questions?
Yes, sir.
Sir, can you repeat on the sketching thing? Yeah, why you came up with these quadrants? Just a bit of it. I didn't get it clearly.
Okay.
And sir, kindly share some of the questions. Some of us are not having the questions.
I wish.
And sir, another question. I think you should get 3. On the part where you are at, let's say, for example, we have got maybe 2x in the sign 2x, maybe let's say.
Yes.
2x. So are we supposed also to maybe to find about to also cross out the 180, which is the range? Can we go further than that?
Look, okay, let me start with the first question as I'll be answering the last one. Then the middle one, I'll just be reading out the questions since I have no platform where I can share you these questions. So someone can send the tutorial sheet in the group. I don't know which group you are. Try to share the tutorial sheet for that person to also have the questions. Help your sister.
Sir, I just want to ask,
Okay.
where yeah, you added 360 plus 30 in the first place, then you divided by 3. But then for this other one, which you found to be 510, you divided by 3, which it gave you 1. How come, sir? But for the other one, it would be 130, and you didn't divide it by 3 again.
No, we did.
That was just a mistake.
Okay, I'll take care. So the first one is the quadrant issue. How do you go to the quadrants? If what I'm given is not directly sine x, Okay, I'm given something like sin px, and the interval they want the x to fall in is a bit big, from 0 to 180. It's possible that in our case, we have sin 3x. It's possible that you can go beyond 360 as you are looking for what you have called theta. Remember, we've called the inside 3x as theta, meaning it's now a standalone angle. It's possible that theta can be above 360. When divided by 3 to form x, it can reduce to the required interval 0 to pi, meaning 0 to 180. So what we are doing here is, because we are seeing such a possibility, we have gone beyond 360, looking for a coterminal angle to 30. Coterminal angle is an angle that starts at the same point and also end at the same point with the angle that you are having. So I'm having 30. I'm looking for an angle starting at 0 and ending in the first quadrant where 30 also ends, which is I add 360 a full circle plus 30, meaning now I go beyond, but it still lands at the same 30 in terms of properties. So we get 390. When you get 390, you divide it by 3 for you to have x. So you're going to have 390 divided by 3, which is 130. We're also seeing a possibility that if we go beyond 360, all the way up to where 150 ends, we'll have 360 plus 150, which is 510. Divide 510 by 3 to form x. Oh, I get the confusion. It's like when I came here, I'm not bringing 170 here. I'm supposed to bring 510 here. So that when divided by 3, it will give us 170. Then change this to that. Okay, good. So you have 17 pi over 18. Okay. All right.
Thank you for understood.
Okay, good. So to avoid being in conflict with the majority or the minority, I'll give you 12 minutes. We'll start at 11:20 sharp.
Thank you, sir.
So when you have given when they
So I'll take that question when you come back. So make sure that
be always in RAD's form or
so you use this. These intervals will guide you whether rads or degrees. They always give you a guidance. So at 11:20, I'm not reminding you because I'm not in platform. I'll just start. If you're not here, you remain behind.
So my question, sir.
Yes.
My question, the question I asked about the.
If it was 2x.
Yes, sir.
You could still go beyond, provided when you divide by 2, you are finding yourself in the interval 0 and 180, or in the given interval. They always give you an interval here. Okay. If they gave us from 0 to 360, they would have gone even 3 times.
Okay. So you would have maybe found about maybe 8 angles there.
Yes.
But if it was just X, would have just gone straight, which is 30.
Yes.
And 150. Okay, sir.
Okay.
Sir,
Yeah.
I have a question.
Ask.
Since there it's sin 3x, what if it's sin 4x? Then the range they've given us is up to 360.
You
Do
can
you
go
continue adding the angle?
You
Sorry?
can come 1, 2, maybe 3 there, or even go beyond add up to 180, meaning 360 plus 360 plus 360 plus 30. And what you get, divide by, if you are given 4, divide by 4 to get the value of x.
No, kind of you add, we just add the numbers. Oh?
You're adding the
Like, can you
360,
just give an
meaning the circles.
Yes, like a circle. Maybe for example, this is 5, 10. So from you found maybe 5, 10 as your angle. You're going to add 3 plus 5, 10, 360 plus 5, 10.
When you go around for a second time, yes.
Oh, all right. Thank you.
Okay. Okay, so we meet at 11:20 sharp.
Yes, sir.